Hello, everyone. Thank you for coming today, and welcome to Xconomy's second annual robotics forum here in Silicon Valley. My name is Wade Roush. I'm chief correspondent and San Francisco editor for Xconomy, and I want to start by introducing our host today, Curt Carlson, who is the president and CEO of SRI International, and he's going to just say a few words of welcome.
Quite a setup here. Thank you, Wade. So welcome, everyone. Every year this seems to get to be more exciting. Wade, you and your team really appreciate partnering with you. This is obviously an exciting area. It's Robotics Week, which makes it doubly appropriate. I understand we have over 1 million robots, and I think robots are growing faster than humans, so that's kind of interesting too. If you haven't been to SRI before, we have 2,300 people in the research part. We do biotech, infotech, and nanotech, and obviously robotics. You saw that we created the first intelligent robot, which is in the computer museum down south from here. And we have a lot of activities going on. We formed 2 companies with our partners here. You'll be hearing about them. We form at any given time, we have about a dozen companies that we're forming here, and we spin out 2 or 3 a year. You probably know we did Siri on the iPhone, and Steve Jobs personally bought that company from us. And kind of interesting, he personally bought it from us. And obviously, the kind of Siri interface that you see and the kind of work that we've done now that goes well beyond that is going to be an interface to a lot of these kinds of intelligent devices as we go forward. Also, I think we have a wonderful agenda for you today. One of the big issues in the world today is jobs and innovation, and particularly robotics. I'm really looking forward to that discussion. We had a session here 2 weeks ago where we invited some of the leaders from around the world to discuss that topic. Tom Friedman was here, and lots of folks like that. And no one really knows how to think about that. So I'm sure by the end of today, we'll have a good answer to how we ought to think about whether we're creating more jobs or destroying more jobs. It's certainly a time of abundance in terms of opportunities, certainly in robotics, but in just about every other area as well. And it's going to be interesting to hear as we move into a world where there's zero inventory, zero delay, and absolute personalized, one-of-a-kind production for all of us for the products and services we want. So with that, Wade, I want to thank you and all welcome to SRI and to the Robotics Conference.
Thanks, Curt. Thanks so much. Some housekeeping, some thank yous to get started. So, of course, we are primarily and first and foremost thankful to SRI International. This is the 3rd or 4th event that Xconomy has put on here at SRI, and they're fantastic hosts, and there couldn't be a more appropriate setting for this particular event than SRI, which, as Curt was saying, has such a rich history in technology and in robotics. I'd also like to thank our event sponsor, Silicon Valley Bank, which is in its 30th year now here in Silicon Valley. I would like to thank our media partner, the Robo Business Leadership Summit, which you should all sign up for. It's in October in Santa Clara this year. Also, we're proud to be part of National Robotics Week. We timed the event to coincide with everything else going on in, around robotics across the country this week. And I think that was a big boost for this event. Xconomy's national partner is Alexandria Real Estate Equities. And our underwriters include IDA Ireland, Latham & Watkins, Silicon Valley Bank, SRI, and Turnstone. We're very grateful to have their ongoing support. Our venture partners right now are Arch Venture Partners, Avalon Ventures, Silos Group, and Polaris Venture Partners. So this is the most important thing in the whole deck. The wireless guest network, SRI Wireless is the name of the network, and the password is printed on your programs. So if any of you want to blog or tweet or read the New York Times while you're here, feel free. That's the network ID and password. And what's happened? My startup disk is almost full. I kind of knew that. All right. And I'm pleased to announce that we, after months of preparation, have launched something new at Xconomy. It's called Experience. You can find it at xconomy.com/experience. And it's kind of a consumer-oriented section of the magazine. You can think of Xconomy as oriented mostly toward entrepreneurs and innovators and investors and the creators of technology. Experience is something different. It's a section aimed at the consumers of technology, the people using the stuff that everyone else we write about is creating. You can also think of it sort of as the weekend or lifestyle section of Xconomy. So all of you guys who are building during the week, you can kind of pick up Experience on Friday or Saturday and read about trends in technology, get yourself oriented to the latest apps, the latest services. And we just launched it. It's been online for a couple weeks. We're going to do a big announcement next week, and we're pretty excited about that. So I wanted to just mention it. Okay. This is where I kind of take over the mic for just a couple of minutes and try and kind of give you the framework for the event and explain where we were coming from when we set out to create sort of the panels that you're going to be hearing today and when we set out to invite today's speakers. And the framework is this. So this is an event about how the field of robotics is going to transform the economy. For decades now, we've seen the power of robotics in certain kinds of manufacturing, especially on assembly line settings. But now robots are finding their way into many other kinds of workplaces, including traditionally human-centered workplaces like the office or the hospital. And that opens up all sorts of new business opportunities for innovators and entrepreneurs. And highlighting their work and its potential impact and its current impact is really what this event is all about today. But all of this is happening in the setting of some serious economic uncertainty. Nearly 5 years after the onset of the Great Recession, unemployment is still high at about 8%. It's down from its peak of 10% in 2009, but it's still higher than it has been at any other time in the last 60 years, except for the two recessions in 1975 and 1981 to 84. So the economy is not creating new jobs fast enough to even keep up with population growth. And when you look at other measures like corporate profits or the stock market, and how they're reaching record levels, you can kind of understand why average Americans might be puzzled, and some economists too might be puzzled and concerned about what's going on with the jobs picture. And whenever a period of high unemployment lasts this long, you begin to hear people wondering whether it's not just some sign of a business cycle, but maybe something more sinister going on, such as perhaps a drop-off in innovation, or maybe even a change in the very nature of work. And you hear a lot of people asking whether automation is a factor and whether technology is displacing workers faster than the workforce can adapt through training and education. In fact, scholars like Eric Brynjolfsson and Andrew McAfee at MIT have wondered out loud whether there's, quote, whether many workers are losing the race against the machine. That's a quote from a recent book that they published. So this kind of thinking that the nature of work is changing and that workers aren't keeping up anymore, it's kind of getting closer and closer to the mainstream of economics. That debate used to be kind of on the fringes, but now it's getting more to the center, and it's also being picked up by the national media. And if there was one example that kind of crystallized the whole media debate, it was a report that ran on 60 Minutes back in January, and I'm sure that many of you saw it. It was called The March of the Machines. And I won't dwell in details, but the overall point of that report was that these tremendous advances in automation, including robotics, are coming at exactly the wrong time. They're happening at a time when workers aren't prepared to enter the more skilled jobs of the future, and that in the short run at least, we may see continued high unemployment. And that meme has kind of popped up in plenty of other places. It's not just 60 Minutes. We've seen it in The Economist, the New York Times, even Wired, of all places. So it's not my job as a journalist to tell anyone in the robotics industry about how to do their business, but it does seem to me that the industry hasn't yet mustered a convincing response to this meme. There have always been times when technology has temporarily raced ahead of our ability to train and educate more people. But historically, those same revolutions have always opened up the way for new businesses that do create millions of jobs. So that's the side of the story that hasn't been told so far. And when we started to plan this event, we kind of knew we wanted to highlight that side of the story and try and bring some balance back to the conversation. We're super lucky and honored to have quite a few folks here from the media, and I hope you'll introduce yourselves to them and have a talk with them, share your thoughts about what you're working on and how these new types of industries, how new types of industries might be created through robotics. And also, there's plenty of other stuff to work on, of course, which includes making sure tomorrow's workers have the skills they need to take part in these new industries. So that's my little spiel. Thank you for putting up with that. And at this point, it's my great honor to introduce Rod Brooks from Rethink Robotics. He's come out all the way from Boston to give our opening keynote talk, and he's going to talk about what's going on at Rethink Robotics. And their work, as you're going to see right away, is on the verge of changing the way we think about various kinds of manufacturing. So Rod, thanks so much for coming.
And I'd like to thank Xconomy and SRI. When I came in today, I came over to Building E. I've been going to Building E for 36 years with the AI Center there, so it was great to be back again. And also, I just want to follow up. I think Curt said there's 1 million robots out there. Later, you'll be seeing Colin Angle from iRobot, and iRobot has shipped almost 10 million just by themselves, so there's a lot more than 1 million robots out there. Okay, so I'm going to try and answer Wade's.
And I'm going to stand here until your presentation is running for sure.
Okay.
All right.
I want to talk about the nature of work and how it affects us all, and in particular in terms of rethinking American manufacturing. American manufacturing has always has increased productivity amazingly well over the last 60 years, but American manufacturing has done that partially by going after low-cost labor. And right after the Second World War, the low-cost labor that it went after was in Japan. Japan had an economy where labor was cheap, and so manufacturing moved to Japan. But pretty soon, the standard of living went up in Japan, and it was no longer cheap to do manufacturing in Japan. But a lot of Japanese companies were built up by that experience. Then we moved over to Korea. Okay, Korea, that's got cheap labor. Let's go there. Let's go and do our manufacturing there. We outsourced manufacturing of low-cost goods to Korea, and their standard of living went up, and new companies came up, Samsung, LG, etc. Ooh, we'd run out of low-cost labor there. We moved to Taiwan. Taiwan, we went into. The standard of living went up in Taiwan. Lots and lots of Taiwanese companies, now brand name companies, came as a result of that. We still kept looking for low-cost labor. Now the story changed a little bit. We went into China via Hong Kong, and it wasn't new companies in China that moved up. It was the Taiwanese companies continued to operate, but in China. And the standard of living has gone up in China, in the manufacturing part of the country, the southeast, over the last few years, and labor has gotten expensive there. By the late 90s, if you wanted to do sewing of toys, it was already too expensive to do it in China, and that started to move down to Vietnam. Again, the Taiwanese companies were the ones that followed that. And it's gotten more expensive to do stuff there. It's gotten more expensive all over Asia, in fact, as lots and lots of different companies have moved into different places. And so it seemed to me that we tend to think of the current situation as being stable, but low-cost manufacturing has been moving around for the last 60 years. So any snapshot we take at any particular time is not stable. And so something else has been going on for the last few years. People have been wondering, can we do this manufacturing back in the US? We're running out of places to go and do, get low-cost labor. And in fact, there's a bunch of stuff that's happened in the US. A bunch of people, making stuff. The VCs have been involved, a bunch of inventions, and it's sort of happening all over the country. It's not just in one place, but there's a lot of different stuff happening, a lot of different people trying out ideas. Some of them look sort of scruffy. Is Chris here yet? Chris Anderson? He's one of the makers. Chris is speaking later. He's in the upper right corner there, the former editor-in-chief of Wired, now has his company 3D Robotics. But this is actually rather reminiscent of what things have been like here in the Valley for a long time. Some of us remember these days with the Homebrew Computer Club, and that completely transformed computation, the stuff that those people did. what does it take to transform manufacturing in the same way? And it's more than just inventions. Obviously, as a robot guy, I think about robots, but you need inventions of all sorts to transform manufacturing, but you also need new infrastructure, and I'll talk about infrastructure some, and you also need new business models. And all these three we saw happen in the revolution in IT. It wasn't just inventing the Apple IIe, it was a lot of other stuff happened with it. I'm mostly going to focus on robotics, since that's the theme, but all this other stuff is important, and I'll give some examples of that. So we do need inventions. Inventions have been the core of the IT revolution. And so as a roboticist, I think of robots. Let's use robots for manufacturing. And robots have been used for manufacturing. But the robots that have been used for manufacturing are rather scary. This is an automobile plant. 70% of all industrial robots for manufacturing are in automobile plants. And in automobile plants, they're mostly in the body shop like this. Notice there are no people there. There are no people there for a good reason. It's dangerous as hell with those robots. So the people have to be kept out. And then there's final assembly, where it's mostly people and almost no robots. The two don't mix. And those robots, by the way, oops, I got a little too fast there. Those robots, by the way, are rather mindless. They follow trajectories accurately. And that was the model of industrial robots from 1961, with the first industrial robots, the Unimates, from Unimation, a company that first had its robots in a GM plant in New Jersey in 1961, when computers were really expensive, sensors were really expensive. So those robots followed the same path using hydraulics and then later ladder logic, later electric versions of them. But they followed the same path again and again and again with very little sensing. And that's still what industrial robots mostly are. And when you buy an industrial robot, you've got this empty vessel, and then you have to program it. It's sort of like buying one of these, but it doesn't come with any software. This is a great phone, and all you have to do is hire someone to write a phone app for you once you buy it. And that's sort of the way industrial robots work even today. There's no body of software that comes with the robot. There may be a few little programming tools, but there's no software that makes it intelligent. In fact, the whole idea of making things easy to use so that ordinary users can use them has not applied to industrial robots at all. So at Rethink Robotics, we started to change that, and we built a robot called Baxter, which we started shipping in September, or we started shipping earlier this year. We announced it in September of last year. By the way, Scott Eckert, where's Scott? There's Scott. Scott's CEO of the company. If you want to talk to him in the break, please do. He's okay. We're the only two here from Rethink today. But this is Baxter, and I want to talk about Baxter for a little while as an invention that we think helps manufacturing in the US and also addresses those very issues that you talked about, Wade. I think when you think about those old-style industrial robots, ordinary people don't get to interact with them. Like mainframes, ordinary people didn't get to interact with them. And then when you had interactive computing, it completely changed the whole picture, and ordinary people got to be part of the process. So here's Baxter. I'm just going to show you first how easy it is to train Baxter to do a blind pick and place. So here's someone just grabbing the robot arm, closing the fingers, moving the part somewhere else, pressing the finger button again, and the fingers open. The robot then infers, oh, the task must be to pick up an object over here and put it in that other location. This is blind, no vision involved in this one. So it's going to go to the place that she said, and it picks up the object. It closes its fingers, because last time when she closed it, there was something between them, so it infers that must be what it's supposed to do. Over here it comes, it doesn't like the kinematic arrangement she put it in, so it's rethinking the kinematic arrangement, optimizing the program slightly, goes down, feels the force as it puts it down, lets go of the object. Now we're just going to see from the screen on the face of the robot that same training. So unfortunately it's a little washed out here, but there's a map, a 2D map from above, and as she moves the arm around, you see where the robot is on the map. And she just closed the fingers, and it felt something between them, so it inferred, she must mean for me to pick up something here. She moves it over somewhere else. She presses the finger button again. There's already something in there, so it lets go of the fingers, and it infers that that must be a put-down location, and then the task is trained. Very straightforward, not lots of menu selection. And by the way, this robot is safe to be around. Not like those, don't try that with a current industrial robot. It is not a good idea. Now I want to show you a little more complex task. I'm not going to go all the way through the user interface, but you see down there on the cuff, he presses buttons, and in this case, he pressed a button when the fingers were together and they opened out and felt something, so it realizes, oh, this thing is picked up by putting my fingers inside it and then holding it that way. So to let go of it, I close my fingers rather than open my fingers to let go, and it makes that inference. And in this case, he showed it an array of locations over there that it's going to put the objects in. It's tracking them on the conveyor belt using vision. There's a camera in each hand. In this particular piece right now, the right hand is putting the things on the conveyor belt, and the left hand is taking them off. You see the face of the robot there with its eyes. It looks in a direction when it's going to move, so that if you're around the robot, you're not surprised by its motions. You infer what it's about to do just by its glances, and it's looking around all the time, so you don't get surprised by it randomly moving when you're not expecting it. Here, it's picking objects up. Notice the conveyor is going the other direction. You don't have to give it the speed of the conveyor or the direction. It just figures that out from vision. It's looking for different objects with the different hands here. The right hand, which is on the left screen, has a vacuum gripper on it this time. It's going and picking up these flat objects. The left hand, which is on the right of the screen, is picking up these small cups. And then it's the white plates are being stacked in 2 piles of 4 in this plastic container, whereas the little brown cups are just being dropped into a box. Again, you didn't have to go through a lot of selection to make that happen. The interface is such that simple things like this are really easy to show the robot. And the goal here is that ordinary factory workers can show simple tasks to the robots. And we try to let the robot do the engineering for the user. So we don't have universal hands for robots, so you have to customize the fingers and either put on some of our fingers with different sizes depending on the task, or a lot of our customers are now 3D printing fingers. But when you put the fingers on there, the camera, which is right at the bottom of that cuff, see the fingers, and that gets in the way of seeing objects. So instead of saying, oh, then the user better give a 3D model of the fingers to the robot so it knows what its own fingers look like, instead it just looks at the background here, moves the hand around, and you see there the little yellow marks are the fingers when the fingers are closed, and the blue ones are what it looks like when the fingers are open. So it adapts to what its hand is doing, figures out how to extract that from recognizing objects so that the user doesn't have to go through complicated stuff for it. So it's like these devices, these cell phones. Make it easy for ordinary people to use. Maybe you give up a little bit of the functionality for that. In the easy interface, we do have ways of going in and doing more complex things. So simple things are simple to train, complex things are possible. Here's the robot in a plastics factory in Pennsylvania. This is a customer-owned robot packing plastic objects into boxes. Where's my clicker? I'll come back to that in a second. Oops. Where are we? Are we still there? Click. Come on, click. Click. Uh-oh. Did your computer just crash, Wade? I hope not, too.
Maybe the video wasn't quite done?
It wasn't quite done, and I broke it. Do you know anything what to do here?
Well, let's just try playing it all the way to the end.
Oh. Is that going to work? Oh, now it's back at the start.
Okay, let's go to the next slide.
Ah, are we there? Yeah, okay, great, thanks. So this is Mildred. Mildred's actually a factory worker in a small company in Connecticut in a plastics factory. This is an hour after Mildred had first seen one of these robots. I don't know whether she has a high school diploma or not. She's worked in this factory for over 20 years. But an hour after she'd first seen one of these robots, she had trained it to do a task, a useful task in the factory. And that's what we're aiming to do. Make it easy for ordinary workers so that it's not a matter of, if you want to use a robot, you have to go through incredible retraining. You don't have to go and get training to use one of these. You know, we don't have to go off to community college to learn how to use our intelligent phones. Make it so that ordinary people can use it, and then they can use them as productive tools. And so that's the sort of thing that we're aiming for, although we do provide capabilities to have hooks to more complex systems, manufacturing, engineering systems, etc. By the way, Mildred is very typical of factory workers today in the US in that she is, she's more my age than Alex Tausig's age. That's what the factory workers today look like in the US. They're older. Oh, now I'm going to have to click everything by hand? Yeah. Oh, I saw it. Sorry, I wanted to say, Mildred, by the way, she's getting older. It's harder for her to lift heavy things. Repetitive work becomes harder. So Mildred changes from being a line worker to being a robot trainer. And that's how we see the future of workers in American factories. When we went out to factories and asked, we were trying to do an ethnology study of workers in factories, trying to find out how they thought about their tools. One of the many questions we asked them was, do you want your children to work in a factory like you? Universal answer, no. They did not want their children to work in factories. And there is not that many young people going into factory work. So if you talk about robots displacing factory workers in the US, with these sorts of robots, in fact, they're augmenting the existing factory workers, letting them do more stuff, because there are no replacement workers coming along. And by the way, there are no replacement workers coming along in China. You know, we talk about peak oil. When did peak oil happen? Peak 19-year-olds has happened in China. We've gone through peak 19-year-olds. And the 19-year-olds are the workers in Chinese factories, so they're on the way down. Has a big implication for their military too, by the way. The robots are letting ordinary factory workers do more. In fact, at that plastics factory that I talked about, showed a little bit of in Pennsylvania, the ordinary factory workers who had never seen a robot, 2 days after the robot first got there, had become the owners of the robot and were the ones doing new tasks with it. They were not trained people. They didn't know anything about quaternions or six-dimensional vectors, which ordinary robot programmers know about. They just knew how to use this interface and started to use their native intelligence to use that interface to do new tasks that the factory management had not considered. So Mildred is typical of current factory workers, and we've got that's just the tip of the iceberg, actually, for all of us. The population in China, in Europe, and the US is aging rapidly. This is the percentage of adults who are below retirement age. It has gone down slightly over the last 40 years, but it is about to rapidly change. And so the percentage of people who are working age or older who are not retired is going down rapidly. Who is going to provide elder care to all these older people? And Bob, that's you and me. Who is going to provide elder care to us? And it's true not just in the US and Europe, it's true in China too. You know, a third of the population, of the adult population, is going to be retired. That's really going to change our society. Demographics are really going to change our society. It's a little aside. Let's go back to manufacturing and inventions. Obviously, there's lots of room for robotic inventions, but there's other sorts of inventions too. Lots of them are important. You know, we've seen 3D printers. Lots of 3D printers are coming around. But 3D printers can only do so much right now. I think there's room for lots of inventions. If we can get 3D printers that can mix plastic and metal, that's going to let us do a lot more. But 3D printers right now are inherently linear in the volume, because they sort of scan a head around. If we could get high speed, which was volume all at once, that would change the utility of 3D printing. If you could mix electronics in with the objects, that would change 3D printing. But if I was going to start a 3D printer company right now, the place I would look, I would go start a company to build tooling, because tooling is something that we can't do in the US, and it's very labor intensive. Baxter, the robot that Rethink Robotics makes, is made in the US, but we could not get all our tools made in the US. We had to make tools in China, ship the tools to the US, and then we make the robot in the US. But tooling we could not do. And the nice thing about tools, you don't have to have high volume of them. They're all unique. And so if I was going to start another company, Steve, I'm not, I would go and do a, but maybe you can find someone who wants to do a 3D printer for tooling. I think it's a great application. Other things we need, though, we need better CAD. We've sort of got WYSIWYG CAD. What you see is what you get when you do CAD. But there's so much parametric information that could be put in there. And the CAD companies are trying to put it in there, but not in the same way that we have for programming languages yet. And CAD going all the way to manufacturing. So when you build a CAD model, it's not just the 3D structure of it, but it's all the manufacturing information. That can really change the portability of designs and their interfaces to robots and can change manufacturing. So lots of invention space besides robots. Also, however, we need infrastructure. The reason that the computer industry, information technology, continues to grow and expand is there's infrastructure. You just plug into the wall and you've got internet wherever you want to be. There's infrastructure. There isn't necessarily the infrastructure for manufacturing and not manufacturing in the US. There's all sorts of infrastructure you need. I'm going to give one little example, and it's biased, I admit. There's a little company in Mountain View here by 2 Stanford graduates, one of whom happens to be my daughter. Like lots of companies that spin out of StartX, went the Kickstarter route, got some funding, we got a lot of sales. We better build the stuff we promised. And then where did they find the infrastructure to do it? There wasn't the infrastructure available. So they quickly went off to China to get infrastructure. And one of the reasons they were in China was so they could get tooling. They couldn't get tooling made in the Bay Area for the parts they wanted to build. So infrastructure is important as we change manufacturing, and that's where lots and lots of jobs are going to come. They're not going to be the same jobs, but there's jobs in infrastructure. If you change manufacturing, it changes the nature of things. So you need quick scale up for manufacturing. Flextronics, one of the big systems, places you go if you want to do manufacturing in the world. The CEO of Flextronics about 3 months ago was talking about he wanted to do more manufacturing in the US, but if he needed to go from 0 to 5,000 employees in 3 months to scale up some manufacturing, he'd still do that far easier in Asia than he could in the US. There wasn't the scale up capabilities in the US. Scale up. Supply chain dynamism. If you look at how iPhones and iPods are made, the components in there have to support on the order of 60, 70 million iPads or iPhones every 3 months, every season. The supply chain is dynamic. It's not the same supplier supplying the same stuff. It changes from week to week just because of the large volumes. We don't have that in the US right now. And tooling, again, tooling capability is incredibly important. But there's also new business models. And I think as these tools come together, robots, supply chain, 3D printing, SuperCAD, et cetera, we'll see new business models. And that was what really happened it happened earlier, but from 1980 through to now, the business models in the IT industry have changed again and again. Every couple of years there's a new business model, new business model, new business model. Back in Boston, Bluefin Labs, started by Deb Roy, a friend of mine, sold itself to Twitter just 2 months ago. It's a Twitter analytics company. We didn't know we needed Twitter analytics companies 2 years ago, but there's a new business model that's right there. So there's new business models in manufacturing. I'm just going to give one example of how business models might change. So what do we currently do for manufacturing? As a product company, it wants to build products, it does a design, it sends the design to some big factory in China. The big factory in China builds the product, gets sent to the US, and the retailers send it out to the consumers. That's sort of a current standard business model. But we could have a very different business model. We could have a business model in the future with all these tools where the product company sells a design, maybe directly to retail, Now, maybe that's a big box retailer, maybe that's Amazon. The retailer then ships that design out to lots of little factories all over the US, and stuff gets built locally to where it is going to be consumed, shortening the supply chain, and that goes to the customers, either via stores or directly from the factories. So the business models are going to change as we get these new tools. And even just with Baxter, the robot, the business model is going to change for companies. People right now are saying, how can I fit it into my current business? But once you get a new sort of tool that, in this case, ordinary people can train to do tasks, the business models will change. It won't be static. So there's a whole bunch of stuff that can come in terms of new business models. I've given a couple of examples here. There'll be, instead of Twitter analytics, there'll be lots of supply chain optimization companies, big data companies, if you like. All sorts of things can change there. We have all these various players. Just like for the IT space, it was a combination, an ecosystem of players. These sorts of players are getting built out now. Some of them are robotics companies, which is what we're talking about today. But there's a lot of change of mindset needed in different players for them all to work together. And it's all of us here in this room. So we see the interesting things happening where there's this maker movement, people wanting to build stuff. And the maker fairs that are, really started around here. And there's Steve Jurvetson again with his rockets. He builds little rockets on the weekend, and then he funds SpaceX on weekdays and for big rockets. There's a trend, just like this stuff. It was a mixture of amateur, professional, moving back and forth, a whole ecosystem, places like SRI making a lot of that stuff happen. That same sort of thing is going to happen now. And, sometimes the stuff we see out there is a little wacky, a little Steve Wozniak, and not enough Steve Jobs. But there's lots to do out there, and I think we're on the verge of building lots of new things and building them here in the United States, and robots are part of that. So I think, thank you.
Thank you so much. That was fantastic, Rod. Thank you so much.